Hello, I'm Dr. Chris Liu, and today we're going to do a brief chemistry demonstration on ions. Ions are positively or negatively charged particles. They are primarily molecules or atoms that have either gained or lost an electron so they become charged. You see here there's an electrical plug going into the wall wire. Electricity you have in the house, in your building, is basically the flowing of electrons or charged particles. That's how you get electricity in the wall. And I want to demonstrate today that ordinary ions are actually conductive and carry a charge just like electricity in the wall. Chloride, better known as table salt, is dissolved in water. Sodium plus cations and chlorine minus anions form. Evidence that the formation of these ions can be demonstrated with an ordinary light bulb connected to a power source. When sodium cations and chloride anions are present in the water, the light bulb will illuminate, as shown in the diagram below. Without the presence of these ions, the light bulb will not illuminate. To begin the demonstration today, I'm going to fill 2 ordinary beakers with tap water. Here's beaker 1, so beaker 2. As you may or may not know, tap water is not really conductive. There are no ions in tap water. So the tap water by itself will not carry a current very well. So in order to make one of the water samples more conductive, I'm going to add ordinary table salt. When I add table salt to the water, it will produce Na plus sodium ions and Cl minus chlorine ions. So you have the sodium cations and the chlorine anions, and I'm going to give this a little bit of a stir. That's probably good enough. You don't have to dissolve necessarily all of the salt. Now I have an ordinary light bulb connected to an outlet, and we have 2 electrodes. One of the wires is actually connected. These are the 2 electrodes where there's a junction or gap in the current. I'm going to stick these electrodes into the plain water as a show. And now I have, with the little red switch, when I push the button, nothing happens. As you can see, the light bulb does not light up. That is because water does not carry a charge. It is not conductive. There are no ions in the water. Now I will take out the electrode carefully and stick the electrode in the water, the salt water. And now when I pick up the switch and turn it on, we should see that the light bulb now glows. The light bulb is glowing because the sodium and chlorine ions are actually carrying the charge from the electrode, from the wall outlet, through the water and to the light bulb. And to repeat the demonstration, if I were to put the electrodes once again into the plain tap water and turn on my switch, the light bulb does not glow, and the light bulb does not glow because there are no ions in the water to carry the electric current or the charge. If I were to repeat the process and stick these electrodes in the water containing the sodium and chlorine ions, like so. Turn on my switch, the light bulb lights up because the current is carried through the water because of the sodium and chlorine ions.